Here's a quadratic equation for us to solve. We know it's a quadratic equation because the highest power of the variable is 2. When we solve quadratic equations by factoring, we want to have all the terms of the polynomial on one side of the equation and 0 on the other side. We don't have that in this equation. We need to bring the 13x and the 10 term over to join them with the 4x squared term. You might say, well, wouldn't it be easier just to move the 4x squared term to the other side? But that would require us to subtract 4x squared, which means over here it would be minus 4x squared. And when I'm factoring, I like to have a positive coefficient for the squared term. So rather than moving the 4x squared term, since its coefficient is positive, I'll move these terms instead. The way we would have to move those terms is to subtract 13x to take it away from the right side, doing the same on the left side, adding 10 to get rid of it on the right side, adding 10 to move it here to the left side. Now our equation is in standard form, and we can solve this quadratic equation by factoring. There's no common factor that we can find that we can divide out of each term. Trinomials, when they factor them to the product of two binomials. We want to check now what signs need to be in those binomials. Since this is an addition here in the second sign of the trinomial, additions come about by two additions in the binomials or two subtractions. And we look at the first sign of the trinomial to tell us what to use. Since this is a subtraction, we will have two subtractions in our binomials. Now, what factor pairs would make 4x squared? That would be 1x times 4x, or 2x times 2x. What factor pairs would make the third term, in this case 10? That would be 1 times 10, 2 times 5. Now we need to pick one pair from the first group to put into the first positions of the binomials, one pair from the second group to put into the second positions of the binomials, and find the right combination that will make minus 13x for us. Let's try the 2x and 2x pair, and the 2 and the 5 pair. Under the O of FOIL, that's going to give us minus 10x. The I of FOIL will be minus 4x. That gives us minus 14x, not the minus 13x that we need. So that's not the correct arrangement. And if I were to interchange the 2 and the 5, or the 2x and the 2x, I'd actually have the same two binomials. That leads me to believe that the 2x and the 2x are not going to work. So I think I'll try the 1x and the 4x with the 2 and the 5. Now under this arrangement, the O of FOIL is minus 5x, and the I of FOIL is minus 8x. Those two terms combined to the minus 13x that we need, we have our factorization. Now we analyze these individual factors to see what value of x would make this quantity become 0, or what value of x would make the other binomial factor become 0. Remember, if one of these quantities becomes 0, the whole product is 0, making the left side the same as the right side, which means we have found a solution. This binomial factor is relatively easy to analyze. it's relatively easy to see that if x was 2, 2 minus 2 would give us 0. So that's one of our solutions. 2 minus 2 would be 0. 0 times anything would be 0. We have a solution. This binomial factor is a little more difficult to analyze. Remember, when you confront one like this, take that factor, set it equal to 0, and form a linear equation that you can now solve for x to tell you what value of x would make this quantity become 0. 0 times anything would be 0, the solution. Let's add 5 to both sides, and then divide by 4, the typical way we would solve a linear equation like this. So if x was 5/4, 4 times 5/4 would be 5. 5 minus 5 is 0. 0 times anything is 0. That's our other solution. We've solved this quadratic equation, which we first had to put into standard form by moving these two terms, the 13x and the 10, to the left side to combine them here with the 4x squared term. That formed a trinomial which we could factor in order to find those solutions.